right, everybody, take your seats, please. Sorry, we're running a little bit behind, so we'll try to get this moving. If you haven't scanned your ticket yet, please see one of the attendants so you can get your CEUs. Also, too, if you have your phones, please put it on silence, please, as the speaker's talking. And if you need to take a call, you can take it out into the hallway. We're running a little bit behind, so we'll let the presentation go ahead, and then a quick question and answer period afterwards. All right, we'll get going since we're a little bit behind here. So this is what is corrosion in water infrastructure and how to stop it. And we have today Brent Williamson. He'll be doing the speaking today. He's with IPP West. So Brent has worked in accounting or sales for 15 years, and 8 of those years specializing in the education component. Over these years, Brent has done hundreds of presentations to engineers and operators. Corrosion and prevention and protection have been a primary focus of his presentations. He is a dynamic speaker and engages his audience, so be prepared for that. So let's welcome Brent.
Thank you. Hi, everyone. So thank you very much for joining me here, and everybody online. How are you doing? I do like to engage you guys, so I'll probably be talking and I'll probably be waving my hands around a lot. And let's try to make it more fun. I know you guys are here to listen to a lot of presentations, and sometimes when you hear a presentation and you see a lot of things on a screen, it gets, you know, pretty boring maybe, or you're reading a lot and you don't want to read a lot. I want to make sure that you guys are having fun too. So why don't we start out with a magic trick? What do you think? Is that fun? Okay, cool. So I need a volunteer. Is anybody willing to come up? Cool, come on up. Okay. Well, can you? No, okay. Okay, I'll stand by the microphone so they can see me online. But anyway, all we're gonna do is just say stop on there anywhere. Right there? Okay. So here it is. Here's your card, so you can see it. Okay, why don't you do me something? Do me a favor, just put your initials right in the middle, okay? Okay, so there's no other cards that look like that, right? That's her only card. No other cards can look like that. Okay, what we're gonna do, put the rest of that down. You hold this side. Okay, and all I'm gonna do is bend it. Okay? Okay. We're gonna bend it up. We're gonna. Now you take that last part off. Okay, so it's gone, right? Okay. Let's go. Go ahead. Yeah. Okay. Can you hold it for me right there?
Oh, wow.
So it's back, right? Are we gonna have fun now?
Yeah.
Okay, cool.
Wow. Can I go?
Yeah, you can go.
Okay.
You can keep it. That's your name on there.
Oh.
Yeah, you keep
Yeah,
that. That's a souvenir. Okay, let's have fun now. Everybody's having fun now, right? So what's cool about corrosion is that, first of all, we have to know where it comes from. And we've been dealing with corrosion in metal for thousands of years. That's why you have all that. But you didn't think you were going to have a history presentation too, right? Back to high school, guys. Okay, but we define our generation by metal that we use, right? So the Bronze Age, for example, the Iron Age, for example, anywhere up to now, we are defining what we do with metal and with the ages that we use. So how do we deal with that? And you're going to learn about different types of corrosion. I want you to know about all types of protection when we're dealing with corrosion. I am now representing IPP West, which is Integrity Pipe Products West. We deal with anodes, we deal with Denso, but there are different types of protection out there. And I'm going to show all of them to you. I'm going to show you what they do. I'm going to show you what the downfalls of them are, what the benefits of all of them are. Because I'd rather you use something and think about corrosion in some way than use nothing. Okay? What about this, for example? We're going to learn about different types of corrosion. This is the bronze statue that was found in England, actually. It's Roman. It was in the ground for 2,000 years. Why isn't it gone? Why isn't it? Why does it? It looks exactly like that 2,000 years ago. Now it's like that. Why isn't it out there? We're going to learn why, right? But first, what I'm going to teach you is, where am I getting all of this information from, right? Where am I getting it from? Well, I'm getting it from several places. NACE, I'm getting it from the American Petroleum Institute. I'm getting it from tons of different places. So I'm trying to collect all that stuff and put it together for you. Sorry, I'm used to walking around and talking and engaging people, so I'm not used to standing behind a podium, but, oh, can I use that? Great. Sorry, camera guy, you're gonna have to follow, right? All right, cool. Did it work? Hello? Hey, guys. Did it work? Can you hear me? Can you hear okay? Oh, there we go. Okay, so when we're talking about that, that's where I'm going to get it from. But here's a fun fact for you. Everything that we're going to talk about and everything that you're going to learn is all in the vitamins you take. Magnesium, phosphorus, copper. There. Is it better over here or whether? Okay, so that's your fun fact. What is this, guys? I mean, you can shout it out, but I'll tell you, it's kind of redundant. But what is that? What causes that? First of all, what is it? It's called tuberculation, is what it's called. And tuberculation is when iron oxides attach itself to an iron pipe. Okay, and so they... Here, I'll go. Can you hear me? So how is that prevented? What do we do? Well, it's pretty simple what we do to prevent that. Anybody that deals with iron pipe now, when you buy new iron pipe, you never see this before. How we do it. That's how we prevent that happening. We put a very, very simple cement mortar lining in it. Why does it stop it? The iron oxides in the water don't know that the iron is there, so it can't corrode. It's impossible now. So we're going to learn what different types of corrosion are there and what are they. So I'm going to trick you a little bit here, but is this corrosion? Yeah, sure it is. Sure, it's corrosion. Was she always green? Nope. She was bright copper when she was given to them by France. It was bright. They were actually meant for it to do that. Some corrosion is not bad. This is good corrosion. Okay. So this little piece of it. Should I stand over here? Yeah. Okay. Have this back. So this thin piece of copper sheeting on there has actually been protecting the iron underneath it now for over 100 years, right? So they wanted it to corrode. But what about something like this? Is that corrosion? Yeah, it's corrosion too. It's actually the corrosion that we're talking about for metals that are above ground or even underground. There's two types of that corrosion, okay? So we have to think about what they are and how they work. This is Core-10 steel. Here's another look at it. Core-10 steel has actually put a protection of corrosion on that iron or on that steel, and it's protected everything underneath it. Okay, we wanted that to happen. They make signs out of this, highway signs, and it's superoxide. Here's the trick one. Is this corrosion? Yes, but not really. Why is this not corrosion in the sense that we're talking about now? What is it missing down there? Oxygen, yeah. There's no oxygen down there, so what's happening to this ship? What's happening to the Titanic? It's being eaten, right? That's what's happening. So it's not the corrosion that we worry about here because there's no oxygen. So let me look at the two types. Now, like I said, I don't have a lot of slides that have a lot of writing, but these ones are important. So the types of corrosion that we're talking about microbial corrosion and we're talking about galvanic corrosion. They're both important. Microbial corrosion is a biocorrosion. It's caused by microorganisms. Oxidation is another term. Rust is another term. The iron pipe guys hate the word rust, but that's what it is, right? Galvanic corrosion is when a corrosion cell is created by an electrochemical process. So there has to be an electrical connection. That has to happen or you don't get it. Okay, and it's actually simple. Sometimes in corrosion and corrosion protection, we look at corrosion protection as being complicated, and we look at corrosion itself as well. I put it in the ground and it goes away, right? It's not quite that. It's kind of the reverse, really. This is corrosion. That's what we worry about all the time for you guys operators, right? But what didn't they do here? Well, they didn't protect it. They didn't do anything for it. Here's a better picture, okay? Why am I showing you this picture? Well, the corrosion is taking a path here. Why is it taking a path? It's doing that specifically on purpose because it's following the electrical current. And it's not just you put it in the ground and it corrodes. It didn't corrode. If you're looking at this like a clock, it didn't corrode at the 12 o'clock and the 6 o'clock level. It corroded at the 9 and the 3. Why? That's where the corrosion is. And that's where the electrical current is jumping off of that. So you're going to hear me say this a lot, but it's an electrical chemical process, okay? So let's look at galvanic rankings, for example, okay? When we're talking about it, we're talking about magnesium, zinc, aluminum. Those are all highly corrosive metals, right? That's why we make anodes out of them. We want those to get corroded before we want the iron or steel to get corroded, okay? What's all the way at the top? Gold and platinum, right? Brass is another one that doesn't corrode very much. Copper is pretty good, but gold and platinum don't corrode. Well, can't really make pipes and we can't really make bridges out of gold and platinum, so we have to figure out a way to protect them, right? So let's talk about potentials from the metal to the soil, okay? So we have less noble and more noble. Here it is right here, okay? So when I'm talking about, when you see this, it's kind of confusing a little bit because we're talking about an electrical current, but I'm talking about minus numbers. Okay, what do I mean by that? Well, it's really important to understand because what I'm talking about when I talk about minus numbers is I'm talking about the energy that's getting taken away. Okay, when we make a material, whether it be a pipe, whether it be a valve, whether it be a restraint, whether it be a bolt, whatever we make, we put energy into it. We melt it, we form it, we shape it, we do whatever we have to do to make it. We pack it, we put it away, and whatever it is, we add a bunch of energy to it. What the corrosion is doing is it's taking away that energy with it. Okay, so when, for example, iron, when it corrodes, it'll corrode at about minus 525 millivolts. That's an incredibly small amount of energy, okay? We're talking about a little battery like that, 3 volts we're talking about. So it's not a lot of energy we're talking about. So what can cause that? What are things that can cause that? Well, the soil itself can cause it, depending on what the soil is, whether there's iron, there's the redox value in the soil. So that can cause it. A rail line can cause it. A power line can cause it. Anything that's causing a stray current can cause it. It can be anywhere. It truly can be anywhere. It's not a matter of my soil. If you're talking about an engineer or that's been designing your lines and you guys are installing them or the operators are putting them in and they're saying, well, our soil's not corrosive. That can change. They put a road nearby or they put a rail line nearby. They put a power line. They put a new subdivision. They dug up some soil that they didn't know. Now all of a sudden you have a corrosion cell that you didn't know that you had before. It can be anywhere. But let's look at the ingredients. Okay, you only need 4 things. If you don't have one of these 4 things, you don't have a galvanic ranking of corrosion, okay? It doesn't happen. So we have to have these four things. We have to have a cathode, an anode, a return current path, and the electrolyte. So the electrolyte is the soil. That's the soil. The return current path is the metal component, whatever the metal component, in this case it's a pipe, but whatever the metal component is, that's what it is. And it'll always corrode at the anode part, which is why we have sacrificial anodes that we put on, right? So what if we took one of these things out? Well, then we don't have a cell anymore. Let's do it, since football season has started, let's do it with a football analogy, okay? We need a ball. We need two teams, a cathode and an anode. Winning team, a losing team. We have to have that. We have to have a place for them to play, which is a field. If I take the field away and they're just playing on nothing, can't play a game. It's just that simple. Whenever I talk about electricity and electric currents and millivolts and amps and all these things, everybody thinks that that's the stuff that's it's hitting the pipe, it's attacking the pipe, or it's attacking the metal component. It's not what's happening. They think it's this. They think it's this big current that's attacking it, but that's not what's happening. The energy is leaving. And what's happening is the energy is leaving and it's taking the metal with it. That's what corrosion is. Okay, so it's de-energizing metal components. And I have a really great picture here that'll show you exactly how it works. It looks just like this. So we're looking at this piece of pipe and it's not broken yet. It hasn't broken yet. What's happening? Well, it kind of looks like an apple crumble on the top there. That's where that energy is starting to leave. That's where the energy has jumped right off of that pipe and it's gone somewhere else. It's gone to a different place that it's attracted to. So it's jumped off that pipe and it's gone on to something else, and it's taken that energy, that metal, and it's gone with it. And as soon as it gets down to the cement mortar lining, boom, you have a leak, right? So what do we do, right? First of all, what's the cost? What's the cost of corrosion? Well, we have all these things, and you guys being operators, a lot of you being operators, this is what you deal with: system downtime, cost of exposure. There could be damage to property, for example. This picture was due to corrosion. This was a pipe that they didn't know was leaking, and it leaked for a long time before it created a sinkhole, and then bam, you have this problem. Okay? Legal liability, loss of life is possible, but we're just trying to scare you there. But let's be real. So the Canada's never done a study on this, but the US has done a study on this, and we have done a study on cost of corrosion. So let's use the US, and I'll break it down for Canada. But the US did a two-year monetary study, and the direct effects of corrosion on infrastructure was found to be about $276 billion a year. That's a big number. What is that per person? About $1,400 per person, per household, every living person, $1,400 a year. How do you pay for that? Well, you don't get a corrosion bill in the mail. You don't get, hey, this was your yearly cost of corrosion. You get it in taxes. You get it in water costs, all that stuff. So anybody will have to pay $1,400 a year down there. What does it cost for Canada? Well, if you extrapolate the numbers, which is about the same, we get about, what, $363 a year per person. Doesn't matter how old they are. So you have to, there is a way to stop it though. Like, there is protections out there that we can completely eliminate corrosion if we do design it into our pipelines and our water lines. We can eliminate it completely. It's not something that we have to worry about. But what are those protections, right? We're going to go through all of them right now. So here they are. So we have Denso petrolatum system, or petrolatum tape system, could be any, but I'm using Denso because that's what I represent. But cathodic protection is another one. We're going to learn exactly how it works, even though a lot of you probably already know. Zinc coating, polyethylene encasement, bonded coatings. Those are the main ones. There's other ones that you can use too, but those are the main ones. So let's start. Okay, this is polyethylene encasement. This is what it looks like. All you're doing is blocking the return current path, like we talked about before. So what's really good about polyethylene encasement? Simple to put on, very cheap. It costs basically pennies compared to the pipeline that you're putting in. All you have to do is put it on, wrap it, tape it, and bury it, and you'll never have to worry about it again. What's the downfall? You're probably thinking of some. I'm not going to make anybody yell it out. I'll say it. But the downfall is when you're talking about bends and curves and restraints and valves that you all have to protect, bolts, all these things you have to protect too. They're all susceptible to corrosion. So what do you do then? Well, I always think of it like this, and it's kind of funny, but have you ever wrapped a Christmas present when you're drunk? Pretty hard, right? Like if you have to do this and you don't know where the tape is, so then you didn't do it right, and it's wrapped this odd shape. It's a lot easier to wrap things that are round or that it's just a square box. But when you're trying to wrap things that have a bend or have a big oddly shaped thing, you start to get a problem. Now you may think it's wrapped, and they'll tell you when they sell polyethylene encasement, hey, you can wrap anything with it. And technically you can, but when you wrap something that's an odd shape, you have a problem. And if you have a hole in it, you rip it that you didn't know, you're going to get corrosion. It's going to happen. So there's your downfall to it. It's not great. It's great for bell spigot pipe, but maybe valves, hydrant, or valve hydrant leads, maybe restraints, anything like that you have to think about. A lot of places in Europe use zinc coating. So what's good about zinc coating? Good about zinc coating is it comes from the factory already done. As the installer, you don't have to do anything. It's already done. And zinc is what? That we learned before, right? It is a less noble metal, so it'll corrode fast. Faster than the iron will. What's the downfall? You created a sacrificial anode on the pipe. You just painted it on. So what it'll last? 25 years? Maybe? Right? In Europe, they use it because they have less aggressive soils than some of the places here. And so they believe the philosophy is that when they put a zinc coating on, that it'll create a barrier just like the Core 10 steel did. But the problem with that is that, first of all, we don't know that's what it's going to do. We won't know for 25 or 30 years if that's what it's going to do. But zinc in itself is a sacrificial anode, right? A lot of places, the oil and gas industry use bonded coatings all the time. And what's good about a bonded coating? Comes from the factory already done. It is efficient, blocking the return current path. It's protecting the metal underneath. What's the problem with it? Well, a lot of oil and gas places will use it, and they don't have to bury it. We have to bury water lines. That's what we do. We bury water lines. What happens when you bury this in aggressive soil? Scratches, holes. What happens when you get a hole? It's actually called something specific. You guys probably have already heard of it. It's called a holiday. And when you get a holiday in a piece of bonded coating, you get a super concentrated cell. Everything that we talked about, everything that we've seen, it is now super concentrated. It will go within, if it's a hard, aggressive soil, it'll go within 5 years. You'll have a hole. If it's less aggressive, 10, but it's still aggressive. Okay. What about anodes? Okay. Anodes are a super great, they're awesome way to do it. They will guaranteed protect the material that you're trying to protect because corrosion will follow what it needs to corrode. They'll follow the less noble metal. It's just science. That's what it'll do. It'll corrode the anode before it corrodes anything else. And if you keep up on the anodes, it'll never, that pipeline will never corrode. It just can't. Right? But what's the downfall of it? Well, the downfall of it is labor. I mean, you have to put it on, right? That's your downfall pretty much, is labor, cost, put it on. I mean, sometimes it's not an expensive cost, but it is. There's more things with that. Have you ever seen impressed current? Impressed current is another one. And impressed current is basically a monitored anode. And when you talk about impressed current, so when you're seeing this picture on the screen there, that purple rope you see at the top, that's the anode. And this has to be replaced. That's the downfall. The benefit of impressed current is we know exactly when it's going to corrode and when it's going to fail. We know when that's going to happen. 20 years. You'll have to put it on a schedule. So in the life of this particular pipe, you'll have to replace that anode 4 times. So that's cost in digging it up, right? So that's what we're talking about. But how does it work? Well, remember we talked about currents, excuse me. And we talked about the iron being susceptible at about minus 525 millivolts. Well, you can see where the arrow is jumped off there. That's where it's going to corrode at minus 525. Well, we basically are just joining that. And then what we're doing with impressed current is we're bathing that whole pipe in one current. Let's just throw out a number. Let's just say that it's 900 millivolts. So everything is 900 millivolts across the board. So it'll never corrode. It just can't. It'll always corrode the anode first. That's just the way it'll work. The other one that we're going to talk about is petrolatum systems. And it is a system. Many people look at it like a tape. It's just a tape. It's not. It's actually a system. There's three parts to that system. There is the paste, there's the mastic, and there's the tape itself. What are they? A paste is an oxide barrier. It'll actually protect that. It'll stop oxidation from happening. It'll also make it more adherent to the tape. Mastic, basically, when I talked about wrapping a Christmas present when you were drunk, well, what mastic does is it makes that shape uniform. So now it's easier to wrap and you don't have to worry as much, right? So, and the difference between, say, a Denso's birdseed and somebody else's is it's a polystyrene bead, so it stays the same in every temperature. It's easier to use in every temperature. So if you ever need that. Here are some examples of them doing just a valve, right? Wrapping a valve. And they're just doing that. And they're wrapping the valves, they're wrapping the restraints. You're making it bulletproof is what you're doing, right? They're using that mastic. It's a messy job. Even though I represent the Denso stuff, I'm gonna tell you that it's easy to put on, but it's messy. There's no doubt. So some people don't want to do it. Some guys don't care. But it's easy to put on, but it can be messy. So, but it's a permanent solution. This does not have to be changed or replaced. It's actually very durable. Even when you dump a bunch of dirt on it, it'll still stay the same. It'll actually mold with all that stuff. And if you ever need to repair it, you can rip it off, put another one on. There's the thing. This picture on your side, it's on the right on your side. It's important because you're going to see a closer look of it, but it's redundancy is what we're talking about. And that's how we protect main lines. This is a big line that you're looking at. We may not worry about it in a small 6-inch line, but we're going to worry about it in a line like this. We're definitely, because we have priorities when we're talking about it. We have priorities on what lines we want to protect and what lines are more important than others. Microbial can be costly. Try and get that bolt off. You're not going to get it off unless you cut it, use heat, use a lot of labor to get it off. So that's microbial corrosion right there. So when you put birdseed in Denso, you pretty much get a perfect bolt every time. It's also, there's tons of uses for it. People put it on, in mining, they put it on their hydraulic lines. People can use it in city trucks too. There's lots of places for Denso. So, but the oxidation is also a barrier. So that's what you see there, that the oxidation is a barrier to it. Okay. So there's what it looks like. When you're just putting on the paste, you can do that too. Okay. But it's a permanent solution. You can use it around catch basins, all those kind of things. Okay. There's a new product out. This is called Visco Wrap. And what that is basically you don't have to use any paste. You don't have to do anything to the pipe. You can just wrap this right on. It is permanent though. Once it goes on and you put a fiberglass outer wrap on it, it's not coming off and it's permanent. So you can cut it off, but you're not gonna be able to take it off like an LT tape. But what it is very user friendly, goes on incredibly fast. And it can beat it. It's great for anodes, which is what I would think of it for that kind of thing. We've been asked a lot of places to use, we come up with this Denso spec, and it doesn't say Denso anywhere on it, but it is a friendly Denso spec. So if anybody's interested in for their own communities and they want to learn how I help them be fair to everybody else, but still be able to protect their own lines, that's what we use as a Denso spec like that. Another option for really cheap option and easy one for bolts is zinc anode caps. If you've ever seen them, they're really great for that. Super easy to use. They're probably $4 a piece. So they're really cheap. But when we're talking about all this stuff, like I said before, we have likelihood and we have consequences. What is our likelihood? Well, let's look at them. Likelihood and consequences, okay? Likelihood is the soil itself. What is corrosion that we've learned? Well, when we say redox, it's a reduction oxidation reaction, right? That's what it is. A redox is reduction oxidation. That's what's happening when you're talking about rust or corrosion. And that there's the sulfides, there's the moisture content, there's the water. When we're talking about a corrosion scale, water is only 2 points on that scale. So when you're saying, oh, it's only going to, when I put my metal component, there's a big water table in there. It doesn't matter. The water is only 2 points on the scale. What matters is the soil. What's the contact with the soil? That's what matters. What's the consequences? Pipe size, pipe location, pipe depth of cover. Is there another water supply? That's what we're worried about. Okay. So this is the redundancy. The redundancy is we want, we could do it with this way: Denso anodes, zinc anode caps. That's a bulletproof line right now. PVC is the pipe, bulletproof line. It's never going anywhere. What I want you to get out of this presentation now is that everywhere is iron. It doesn't matter. You're using iron everywhere. Even if you're using PVC pipe in the community, which is a great step, iron's everywhere. We have to find a way to protect it. It's in all these things: fire hydrant, indicator boats, gate valves. I could go on and on, right? Corrosion will attack everything. They're burying this like this. They got a problem in a little while. Here's an example of a community in the lower mainland. Well, it's not in the lower mainland, it's in BC, but that's what they did. They buried that line. That's what it came up within 10 years. The one on the other side is how it should look. Okay. That's it from me, guys. I appreciate your time.
Thanks, Brent. Is there any questions out there? Quiet group, come on. Nobody? All right. No questions. You're free to go. Thank you very much. Thank you, Brent. Thank you, guys.